right. Hello, everyone. Who's heard of PyTorch here? Anyone? OK, so the rest of you are just using APIs, I guess. So ChatGPT, trained on PyTorch, right? Stable Diffusion, trained on PyTorch Lightning. A lot of largest models today are using software that we work with to basically scale up. You'll see PyTorch Lightning in places like Facebook, Lyft, Uber. Over 10,000 companies in the world use it today. I'm going to actually share it with you, a few more stats real quick. How do I do this? Cool. So if you go to our website, you'll be able to learn a little bit more. And basically, before I talk about the platform, I just want to talk about this, right? So these are all open source repositories for fine-tuning, training, and deploying models. We were working on PyTorch Lightning probably since around 2015. It's been a while. And it's kind of the standard way for doing large-scale training. So if you want to go beyond one GPU, multiple GPUs, you have to figure out how to set up all that infrastructure, distribute gradients. There's a lot of stuff involved in there, right? You can either do it yourself, but most likely it's going to be really hard to do. And that's really where the frameworks come in. The analogy that I like to draw is kind of like JavaScript and React. PyTorch is JavaScript, Lightning is React. Most people today build some sort of like weird version of Lightning internally, and then that PhD quits, and then you're stuck with all that code, and you have no idea what to do with it, right? So at this stage of the game, there's not really need to be writing just kind of like regular PyTorch, just like you wouldn't write a website in JavaScript, although you technically could. You'd use something like React. So what does this matter if you're not training your own models? Well, you are going to fine-tune them, or you're going to deploy them. So this helps you do all of that. How you do that is really through things like changing the precision of the model, which means that you can go from 32 to 16-bit precision. What does that mean? It means you get to have cheaper GPUs, things with more memory, right? So you get to save a lot of memory. So it's a lot of these tricks that are kind of hot in the research world that are optimized for models. These are things that you're probably not even aware that you could do. You can just turn them on, and they'll just kind of work out of the box. Now, that's great. However, when you need to do this at the enterprise scale, you're going to need to kind of build your own platform internally. And usually people do that. They kind of string together. They grab something like SageMaker. They bring other tools in-house. They string them together. They build some platform. They put some security permission stuff around it, maybe some cost management. And that's really it, right? Now, fast forward 3 years later, a lot of people get stuck with that platform. The team that built it left, right? Now it's not really working super well. Gen AI just came out, ChatGPT came out, now you need to pivot to train LLMs. You don't know how to do that because your platform was built into 2018, 2019. It was built for data science, where you work on a laptop, on a CPU, you don't really use GPUs. There are a lot of issues that are coming up with that. One of the other big things that you have to account for is the ability to move fast. So tomorrow, last year, most of you had never heard of ChatGPT or GPT in general. If you're a researcher, you knew what it was, right? Transformers with a bunch of other stuff. Now, vector databases came out, and everyone's like, oh, vector databases, right? Well, now you have to change all your tooling to figure out how to adopt those very quickly. So tomorrow, there might be something new, and then you're going to have to pivot your whole platform to do that again. So that we built a platform for that. And this is something that we've been working for about 3 years, and it's deployed at some of the largest companies today. So I'm going to kind of show you a quick highlight of how this works, and then I'm going to go into an actual demo, right? So this is the Lightning Studio here. And if you can tell, what you're looking at here is an IDE, like VS Code, right? You also have Jupyter Notebook on the right if you want. And if you don't want to code in the browser, you can connect from your local laptop. So you don't actually need to be on the browser. And basically, this is going to be running on the cloud. Now, if you notice, I'm on a CPU machine right now. So I'm going to go ahead and let this video play a bit. We're going to take the studio and turn it into a studio for data prep. So every studio can be tailored to one step in an ML pipeline, right? So in this particular case, you can think about this like this one studio is like a hyper tailored ML platform for doing just exactly this one thing you want to do, right? Normally, you'd have to buy a whole platform to do this whole thing. So I'm going to go ahead and switch to a GPU machine here. The data processing that I'm going to do actually requires a model because I need to extract features, for example. So I'm going to actually connect my S3 bucket. This is where the data lives, or I can upload it, right? It takes a few seconds. And this is like our kind of like data lake, I guess, where you can bring in different data sets, image, text, unstructured data. You can connect to things like Databricks and Snowflake, bring that data in as well. But it's all here, and it's ready for you on the platform. Now, in the data analysis side, it's very likely you're going to use a notebook for that part because you need to like plot things, you need to chart things, you need to like understand what's going on. So we're going to switch to Jupyter Lab to do that real quick. And here, we're just going to do standard data science workflow now, right? Except that you're on a very powerful machine. If you turn this machine off, and you bring it back online, everything's going to be exactly the same. The whole environment, the files, the data, dependencies are all there. I can actually code with someone, so I'm going to do that now, right? So you can click on share at the top, and then you can actually just send a link to someone, and they can come on with you, and you can do the analysis together. They can write other notebooks. They can do the VS Code if they wanted to. Now, there's something that happens with large data sets that is extremely hard to solve on your own. Let's say I have like 10 terabytes of images or unstructured text, like emails or CSVs or whatever, and I want to do a transform. I want to just like go to that data, load it in memory, extract some features from it, save it again, and you want to do this over and over. It's like a data pipeline, right? So we have an app here, so the studio can install different apps. This just happens to be one app. This one's called the Data Prep app, and you basically are going to pick the code that's on that studio. So we have the script here, which is going to prepare a data set called StarCoder, and this is just a bash script here. You select the machine it's going to operate on, the number of nodes you're going to use it on, and then it'll just automatically scale. So here I'm going to pick 8 nodes. So it takes the code from the studio and it just replicates it, right? So there's no gap between, oh, it works on my laptop and then I submit a job and then it fails and I can't debug and I can't figure out what's going on. It's just there already. So I can get it to run on the cloud, I debug it, make sure it's fine, and then I take exactly that same environment and I submit it and I ship it to all the other machines. Now I have a high level view of the cluster here, so I'm seeing the 8 machines. I can see the utilization across all of them. I can step into every machine and actually SSH into them, whatever you want. You can see logs. It's very simple, very straightforward. All the stuff happens in real time. So what this is doing is going to read a file. It's going to like map reduce, basically. And I'll show you that in a minute, right? You write a function, you take a file, you do something to it, and you save another file out of it. And you can chain a bunch of these. So this is going to be my data prep studio. That's it. So I'm going to save this thing. I'm going to put it in the background, and I'm going to turn it off now, right? Now I'm going to create a brand new studio, and this is going to be for training a model. So this is like a model training platform now, specifically, right? This is like, this one thing here is like one of our first products called Grid AI, where you train models at scale, or like Mosaic or like SageMaker or something like that. This is that one platform in this one studio now. So I'm going to install a few plugins for training. So for training, you need a few things. I'm actually going to go back a bit. For training, if you look on the right here, you're going to need a few things. You're going to need something to monitor. So we're using TensorBoard here, right? You could use Comet, weights and biases, write your own thing. That's fine. You're going to need an app to do distributed multi-node training, for example, or just do kind of single jobs, that kind of thing. And then obviously you need to code. You have your data lives here, and you have terminal access that you can connect to and kind of do whatever you want. This is just like your laptop on the cloud. That's all you need to know. Like, if you can do it on your laptop, you can do it here. Can you build a Docker image on your laptop? Yes. Great. Do you have sudo access on your laptop? Yes. Can you pip install? Yes. Can you git clone? Yes. Can you run Python? Yes. Can you run a React app? Yes. It's just your laptop on the cloud, right? So I'm going to connect to the web terminal here. And here I'm just going to git clone the repo. So this is one of our open source repos that basically helps you train models really, really fast. So we fuse kernels, we optimize a lot of the model architecture. We do a lot of this stuff with NVIDIA and Google, right? So we have collaborators there. We have an in-house PyTorch team as well that we hired from Meta and from NVIDIA, and they're the ones who created a lot of these at Meta, right? So we're sitting here optimizing kernels, fusing things you guys are never going to want to do on your own. So this repo has it. So I just clone it, just like I do on my laptop, and I just set it up. I actually need a GPU machine, though, so I'm going to switch to a GPU machine with 4 810Gs on it. It takes about a minute. It's there. Now I start training the model there. So now I'm doing multi-GPU training. If you're using PyTorch Lightning, it'll just work out of the box, right? If you're using PyTorch, you have to figure out how to get it to work on multi-GPUs, which is not a trivial thing to do. And if you're using JAX or TensorFlow or sklearn, then it's on you to figure out how you're going to set that up, right? So now I want to monitor what the model's doing, so I'm just going to set up TensorBoard real quick. And I can see TensorBoard's running here. I can share this link with people, and they can actually watch the TensorBoard logs with me and like get on the studio and monitor exactly what I'm doing. But in this case, it's a small model. All I was doing here was mostly debugging that it's going to work. So I trained it on 4 GPUs. Now I'm going to do a multi-node training here. So I'm going to select the script again, right? So it's going to be that particular model. This is the machine that I'm going to use. How many nodes I'm going to scale to. So in this case, it's going to be 8. So this is going to be 32 GPUs for this one model. And I just hit submit. and then it automatically scales. You saw it already with the data prep. It's kind of the same thing for multi-node training. And you can monitor the GPU utilization, all that stuff here. You see the execution happening. And so that's it. This one studio is now done, and it's for training a model. So I've created 2 steps in an ML pipeline now, right? Now, if your pipeline requires something completely random, just create a brand new studio and overfit it to that one thing, right? In this case, I'm going to serve like a Streamlit demo because I want to like actually demo it or get people on it. So I'm just going to install the Streamlit app and then just run it. It takes like 3 seconds. I share the link, I keep the studio running, and it's good to go. So this is nice, but most of the production workflows are not going to be interactive, right? This is really on the building and research and prototyping phase, which I argue is the most important because this is where you're going to spend most of the time, and it's also the slowest part for your teams, right? If you can't prototype quickly enough, it'll take you like 10 months to ship anything. But you can do this all together. It's like 80% more efficient. Now you can take an SDK and automate all of this. So I can import the SDK, and all those 3 studios that I just created, I can just write them through code and orchestrate them, right? Put them into like GitHub Actions, any other pipelining tool you have, and just start them up. So the data prep studio, I can say, cool, start the data prep studio, run it, shut it down, do the server. Another pipeline maybe just trains a model and serves. So you can just mix and match these things as you want. Cool. So you're just kind of seeing that there. We also have a collection of these that are out of the box built, so you don't need to like sit here and figure out how to deploy your own APIs. You can actually deploy models on your infrastructure in like 5 minutes, and you also have control over the model, right? Because most other solutions are like black box APIs, and then when they go down, you're kind of like stuck, right? Here, you actually get the code, so you can actually mess with it. You get the raw server, you can write your own endpoints, you can do whatever you want. So I'm just going to jump to the product now and kind of do what I just did. So I started a studio here, same thing, right? In this case, I'm just going to train a very simple model. So I'm just going to go to the open source here. I'm going to grab a PyTorch Lightning model, kind of the one that I was just showing you. You can bring your own models. You can grab models from open source. It doesn't really matter. So I'm on a CPU. I can see the utilization is fine. Nothing major is happening. So I'm just going to start training this. And so, yeah, give it a second. There it is. So terminal's running, nothing crazy is happening. If you look at the code, if you're not used to PyTorch Lightning, so this is the model here, an encoder and decoder. ChatGPT is an encoder-decoder architecture, right? GPT model. So it's sort of like a very similar version. This is one of the earlier models called autoencoder, but it's conceptually the same thing. And then this is what the training happens. Now, unless you're a researcher or ML engineer, you probably don't mess with this part really ever. What you mess with is the scaling of it. So the trainer here lets you do things like, hey, only train for 10 steps, or train for 100 steps, or train on 10% of the data, or save checkpoints every 2 minutes, or whatever. It's all the configurations happen there. You can also write your own trainer. So I'm training on a CPU, but it's super slow, right? So it's just like 5 minutes to get this thing to complete. So I'm just going to go ahead and switch to a GPU. You can configure this, and this runs on your cloud, right? So these are the machines that you have agreements with AWS, for example. And I'm going to pick like an A10G here. Now, the A100 is going to take 46 minutes to get, so we're not going to do that. We're going to pick the A10G. You can pre-provision machines, so they'll be available very quickly. You can write your own images as well, so it's fully customizable. And here you have the whole environment. You can control everything you want. You have a non-start script, right? So you can basically do something whenever a studio starts, whatever you want to do there. You can customize this with your own kind of like bash RC. So if you're coding and you're like, I want Vim commands and this and that, you can do that there. And every time you create a new studio, all the same stuff gets shared. So you don't have to set it up again ever. Here's the SDK. So if I want to actually orchestrate this one studio, it gives me all the commands to do that very quickly. OK, so the machine is ready. So I'm actually going to switch to it now. Cool. So that took like, I don't know, 30 seconds. And that's it. So I have 4 GPUs. Now, if you notice, I didn't have to install dependencies. I didn't have to move the code. I didn't have to do anything, right? So we snapshot everything. We know how to persist environments across machines. So you can literally go back and switch to a different GPU. This is really good for like prototyping and developing, where maybe you want to you're going to spend a lot of time debugging something in a GPU, but you don't want to use an expensive GPU, so use a cheap one. When you're done with it, you switch to a very expensive one, and actually you train on it, right? So it'll save you a lot of time. Same model. I'm not going to touch anything here. now I can actually just train on the 4 GPUs. I didn't change the code at all, right? And we're adding other hardware. So Trainium's like kind of available here. There's a few other ones that we're adding. And we work with all the hardware vendors to integrate these things, right? So you're not going to sit here and write, like, take all your models and rewrite them in Trainium again, right? So this is what you use PyTorch Lightning for. So now I'm training on 4 GPUs, and I can see the utilization and all that stuff here. So who knows? Yeah, like, a lot of people think the utilization is the best metric to figure out if your GPU is being used. It's actually not, and we tell you that here, right? It's actually power. So when you're at max power, that's actually, the GPU is actually pretty well utilized right now, right? Most of our team are PhDs in AI, so we put all this knowledge into here so that you don't have to go hire 30 PhDs to do this stuff for you. So you can have someone who's kind of like, knows the basics, but we're going to teach them everything that they need to know along the way as they're using the product. Okay, so this thing is training, that's great. But it's kind of like a small model, so I'm just going to stop this thing. I'm going to scale it up to a bunch of nodes, right? So I'm going to go here and find one of the integrations, and this one's going to be for training. So I'm just going to go ahead and do that. So I install that app, and now I'm going to set up a new training run, right? I'm going to use 8 nodes, well, 4, because I don't want to spend $1 million right now. And this is the same model, no changes. This is Bash script, so you can just add arguments, whatever you want on here. Everything I'm doing you can do through APIs or SDKs as well, right? But it's super useful to do it interactively for like actual research and development. And this is as complicated as it is to scale to multiple nodes, right? These machines will provision in a few minutes, and then we'll be good to go. So in the meantime, I'm going to start another studio. And normally, when you train a model and you need to serve it, you basically will need to kind of like share checkpoints and all these other things, right? There's a unified file system under the hood, so I don't have to do any of that. I just CD to that studio, grab the files, and then just deploy them. So it's very, very straightforward. All right, so I'll give this a few minutes to start up. So this is a brand new environment, fresh, different dependencies, everything's completely new. You don't want to do this stuff on your laptop because usually you will break your laptop if you try to like code on this thing and try this other model and this and that, and you have 30 conda environments and you forgot which one you're using, and then you're working with someone and they're like, oh, can I replicate what you're doing? And then you're like, sure, I'll push to GitHub. Can you pull? Oh, but dependencies aren't here. What's the same thing? Blah, blah, blah. That's super, super problematic. All I have to do here is just hit duplicate, and I have a copy of your environment now in about 30 seconds. Right? The code, the dependencies, everything. So there's no sitting here like trying to figure out like what you did that I didn't do. So it's very simple to debug. Or even better, I share the link with you, you join me and we start coding together. And then I could actually help you debug. So if you have like junior developers or new people who are being onboarded, this is probably the simplest way to onboard someone. You just create a collection of studios internally for yourself, and when a new developer comes in, they duplicate them all, and now they have access to the whole system, right? And they can start coding and doing their thing. All right, so this is the other studio. This one has nothing on it. I'm gonna like serve an AI app here, very simple. It's gonna be like Streamlit, right? I could do it in React, Radio, Vue.js, whatever. So this will set up the environment, all that stuff. Yeah, and while that's installing, I'll show you what I meant. So this one's called Breakable Salmon. I'm just going to rename this to Nov30 Train. All right, so that's my studio for training the model. And then I'm going to come here, just going to open a new terminal. And then I can just go up to my other studios here. And you see my other studios there. So I'm just going to go there. And I can copy those checkpoints, right? So that's as simple as it is to get checkpoints or files from other systems, right? People literally buy standalone platforms just to do what I just did in like 5 seconds, right? So this integrates like 30 different point solutions into like one cohesive experience. Okay, so I have my Streamlit here. And then I'm just going to go ahead and start from a template because I'm lazy and I don't want to code it up myself. You can create templates for yourself and for your company. So this is just going to be like a little dashboard that someone put together to look at the rides in New York City for Uber, right? So this will load the template. All right, almost out of time. And I'll run this. And that's it, about 5 seconds, 10 seconds. You'll have the link here. I just copy this, share it with people, and they're ready to go. So here's my app that I'm hosting. You can obviously put this under your own URL, under all your DNS, whatever, all your security settings, right? We deploy in banks, we deploy in all these like super secure areas, but yeah, so I don't know, it's like 10 minutes, and I train a model on CPU, trained it on multiple GPUs, scaled it to multi-node, and deployed an AI web app, and I didn't even have to learn what Docker was, right? So anyways, thank you guys.